Mars is cold. -60 degrees on a good day. No liquid water. No atmosphere worth mentioning. Radiation that would sterilize a hospital floor. Every textbook, every documentary, every scientist interviewed on cable news says the same thing. Red dust and silence. Nothing more. Except NASA's Perseverance rover just found over 4,000 rocks scattered across the Martian surface that shouldn't exist. They're made of a mineral called kaolinite. And here's why that matters. On Earth, kaolinite only forms in one kind of environment. Warm, wet, flowing water. Think tropical rainfall, hot springs, the exact conditions where microbial life thrives. For thousands of these rocks, just sitting there, on a planet where none of that is supposed to happen. But that's not even the big discovery, because while scientists were processing those results, Perseverance drilled into a mudstone in an ancient riverbed and found something that made NASA call it their most important rock ever: organic carbon. Strange circular patterns that on Earth are made by living organisms. The results just passed peer review in Nature. The word they used was potential biosignature. That's as close as NASA has ever come to saying they may have found evidence of ancient life on Mars. And here's where this story takes a turn nobody expected. That rock sample is sealed in a tube on the Martian surface right now, ready for pickup. But 2 months ago, the United States Congress officially killed the mission to bring it back. No funding, no plan, done. Meanwhile, China is building a spacecraft to go collect Mars samples themselves. Launch date, 2028. So what exactly did they find? Why did America walk away from the biggest discovery in science? And what happens when China gets there first? It starts with those 4,000 white rocks. To understand why they matter, you need to understand the story we've been telling ourselves about Mars for 50 years. It goes like this. Mars was wet once. Briefly. Maybe 3.5 billion years ago, some water flowed on the surface. Then the planet lost its magnetic field. Solar winds stripped the atmosphere. Whatever water remained either froze underground or vanished into space. And for decades, nobody questioned it. Mars today seems to confirm that story. The atmosphere is less than 1% as thick as Earth's. Breathing it would be like trying to inhale at 100,000 feet. Your lungs wouldn't register anything there. And the radiation, without a magnetic field, Mars gets hammered by cosmic rays that shred organic molecules at the surface. It's a planetary sterilizer running on autopilot. So when NASA chose Jezero Crater as Perseverance's landing site, they weren't expecting miracles. From orbit, you can see what looks like an ancient river delta feeding into a basin. A dried-up fan of sediment, like a frozen mudslide pointing into a crater 45 kilometers wide. The thinking was straightforward. If Mars ever had water long enough for anything interesting to happen, this is where you'd check. But nobody expected what came next. Meanwhile, 3,700 kilometers away, that's roughly New York to Los Angeles, NASA's other rover, Curiosity, had been exploring Gale Crater for over a decade, and it was finding things too. 2 robots, opposite sides of a planet. Same impossible story. Whatever happened to Mars didn't happen in one spot. It happened everywhere. So here's the question that drives everything you're about to hear. How wet was Mars? How warm? For how long? And the question nobody in the scientific community will say out loud on camera, but every single one of them is thinking, was something alive there? Let's start with what Perseverance rolled over on its very first day. The cameras picked up small, pale pebbles scattered in the Martian soil. They looked wrong. Too light, too clean against all that red. But the team was busy calibrating instruments and running checks. Nobody stopped to investigate some weird little rocks. Months passed. Then scientists spotted larger versions of the same pale stone lying loose on the surface. And these were what geologists call float rocks. They didn't form where they were found. Something moved them there. Finding a float rock is like finding a seashell in a parking lot 50 miles from the beach. It didn't walk there. Something carried it. And whatever carried it was big enough and lasted long enough to scatter 4,000 of them across the landscape. When Perseverance finally fired its laser at those rocks, the mineral came back as kaolinite. And that's when things changed. Kaolinite is a clay mineral. On Earth, it forms under very specific conditions. You need rock sitting in warm, flowing water for a long time. Not a splash, not a flash flood. Sustained warmth and moisture working on stone for thousands or millions of years. Think of it like a rust stain in a bathtub. It doesn't show up after one shower. It takes years of hot water slowly breaking down the surface. That's what made these rocks. Except the bathtub is Mars. The old story was simple. Mars had water once, briefly, a wet weekend on a dry planet. Turns out, these rocks tell a completely different story. This wasn't a weekend. This was an era. And there were over 4,000 pieces of evidence lying in the dirt, waiting for someone to point a laser at them. But it doesn't stop there, because curiosity, over in Gale Crater, stumbled onto something even stranger. A field of rocks made of pure crystalline sulfur, just sitting on the surface, exposed. No clear geological explanation for how they got there. One of the mission scientists compared it to finding an oasis in the desert. It shouldn't exist, but it does. And here's why sulfur changes the equation. Deep in Earth's oceans, where sunlight never reaches, there are colonies of microbes that eat sulfur the way we eat food. No sun, no oxygen, no photosynthesis, just sulfur and water. That's their entire world. Some of the most resilient life on our planet runs on sulfur chemistry. And here was a field of their favorite meal, casually sitting on Mars. We tend to think life needs what we need: sunlight, or comfortable temperatures. Turns out, some of the toughest organisms on Earth need none of that. Just chemistry. And Mars has the chemistry, so we've got the ingredients. The question is how long the kitchen was open. And that's where the next discovery changed everything. In early 2026, a team led by researchers from Imperial College London published findings from a geological formation lining the inner rim of Jezero Crater. They found layered sandstones with rounded, sand-sized grains. The arrangement was unmistakable. Textbook indicators of waves acting in a shoreline environment. They were looking at a beach, not a puddle, not a flood deposit. A beach, with waves, with a shoreline that lasted long enough to carve features we associate with stable coastlines on Earth. And beneath that beach layer, evidence of something even more significant. Water circulating underground through rock over vast timescales. Hot water moving through cracks and pores. Dissolving minerals, depositing new ones, building warm, chemically active pockets beneath the surface. On Earth, we call these subsurface hydrothermal systems. Picture the plumbing of a planet. Hot water flowing through underground channels, creating little pockets of warmth and chemistry. And here's the thing about these systems on our planet. Every time we find one, every single time miles underground or at the bottom of the ocean we find life. And Mars had them. Any one of these discoveries alone would be a career-making finding. But scientists weren't looking at one. They were looking at all of them at once. Warm water minerals, sulfur chemistry, beach deposits, underground water networks, different rovers, different sites, thousands of kilometers apart, all telling the same story. Mars wasn't just wet once. It was a planet with sustained, diverse, habitable environments running for billions of years. 3.5 billion years ago, life on Earth was nothing but single-celled organisms floating in warm oceans. Hadn't figured out how to be multicellular yet. And Mars had beaches. It had hot springs. It had underground water systems running the same chemistry. The question isn't whether Mars could have supported life. The question is whether it did. And then one rock changed everything. In July 2024, Perseverance was exploring Neretva Vallis, an ancient river channel about 4 football fields wide that once fed water into Jezero's lake. The rover drilled into a fine-grained mudstone, exactly the kind of sediment that preserves biological traces on Earth. And when the data came back, the team saw something that stopped them cold. Circular reaction fronts embedded in the layered sediment. Small, repeating patterns that the scientists started calling leopard spots. On Earth, these textures are produced by a specific type of chemistry driven by microbial metabolism. tiny organisms consuming chemicals in rock and leaving behind distinctive circular halos. The rock also contained organic carbon and minerals tied to biological activity. One mission scientist called it the most puzzling, complex, and potentially important rock Perseverance had ever examined. For a full year, outside scientists scrutinized the data, challenged every interpretation, tested alternatives, and in September 2025, the results were published in Nature. The word they used was potential biosignature. This isn't a tabloid headline. This isn't speculation. When Nature publishes that word after a year of peer review, it means the scientific establishment is saying, we cannot rule this out. And Perseverance wasn't working alone. Over in Gale Crater, Curiosity independently detected the largest organic molecules ever found on Mars. Long carbon chains, the kind of molecules your body uses to build every cell wall. The literal scaffolding of biology. Organic molecules alone don't prove life. Non-biological processes can produce them. But when researchers tried to account for the quantities using every known non-biological source, meteorite delivery, geological chemistry, atmospheric reactions, they couldn't fully explain it. The numbers were too high. Their published conclusion: it is reasonable to hypothesize that biology contributed. They stressed this remains unresolved, but the door is open wider than it's ever been. But here's the critical thing. Perseverance can detect these signatures, can photograph the leopard spots, can measure the organic carbon. What it cannot do is confirm. The rover doesn't carry an electron microscope. It doesn't have isotope mass spectrometry. It doesn't have cleanroom laboratory analysis. It's like finding a suspicious substance at a crime scene. The detective can tell you it's powder, maybe narrow it down, but until you get it to the forensics lab, you can't go to court. And the forensics lab is on Earth. The spectrometers, the microscopes, the people who've spent 30 years studying exactly this kind of evidence. They're all here. The evidence is there. Perseverance did its job perfectly. It drilled a core from that rock, sealed it in a titanium tube about the size of a dry erase marker, and cached it on the surface. The most valuable scientific sample ever collected on any planet is sitting on a dry riverbed right now, surrounded by dust and silence. The plan to bring it home was called Mars Sample Return, NASA's crown jewel, the most ambitious robotic space mission ever designed. Think of a relay race where every handoff happens on a different world. Runner 1 is Perseverance, already there, already holding the baton. Runner 2 is a lander that touches down nearby and loads the samples into a small rocket. That rocket launches them off Mars into orbit. Runner 3, a European spacecraft, catches them mid-orbit and flies them home. Miss any handoff and everything fails. Now imagine budgeting that. What started as an ambitious project spiraled. An independent review put the cost at $11 billion. That's more than twice the price of the James Webb Space Telescope, the most complex space instrument ever built. NASA scrambled to redesign, came back with a leaner version around $7 billion. Still enormous. And then the political winds shifted. In May 2025, the Trump administration proposed slashing NASA's budget by nearly a quarter. Mars Sample Return was tagged in the budget document as grossly over budget. By January 2026, Congress passed the spending bill. The language was blunt. The agreement does not support the existing Mars Sample Return program. No funding, no timeline, no plan. The most important scientific samples ever collected, stranded on a planet 225 million kilometers away. If you drove a car at highway speed non-stop day and night, it would take roughly 250 years to get there. That's where the tube is sitting right now. So the samples are stuck. The mission is dead. And that would be the end of the story, except for one thing. China. While America was debating budget line items, China was building hardware. The mission is called Tianwen-3. The name translates to questions to heaven. 2 launches planned for late 2028, each on a Long March 5 rocket, a lander and an orbiter. The goal? Collect at least 500 grams of Martian material, about the weight of a can of soup, and return it to Earth by 2031. If it works, it would be the first time material from another planet has ever been delivered to a laboratory on Earth. And here's what makes this more than just China doing what NASA couldn't. Tianwen-3 will drill 2 meters into the Martian subsurface. That's roughly the height of a doorframe. Perseverance only scraped the top. Why does depth matter? Because Mars's surface radiation is like a bleach wash that's been running for 3 billion years. Everything organic up top has been shredded. Everything Perseverance found survived despite that bombardment. But go 2 meters down and you cross a line. Below that depth, the radiation can't reach. The rock hasn't been touched since it was sealed by geological processes billions of years ago. If something lived on Mars and left a chemical trace, that's where it survived. That's where Tianwen-3 is going to dig. The lander will also deploy a helicopter drone, building on what NASA's Ingenuity pioneered, to grab samples from multiple locations around the site. And the entire operation, landing, drilling, sampling, and return, runs as one integrated mission. Not the multi-stage relay race that pushed MSR's cost into the stratosphere. China learned from watching NASA's mistakes. One planetary scientist, reacting to the MSR cancellation, asked a question that should keep people up at night. She said, "When we've got memos saying we want to be the dominant power in space, how do we leave something this ambitious behind?" The answer so far is silence, because the uncomfortable truth is this. The nation that returns the first Mars sample and analyzes it controls the narrative on whether life existed beyond Earth. If China confirms evidence of ancient Martian biology in a lab in Beijing, that discovery belongs to them. Their science, their labs, their moment, not Houston, not JPL. And let's be honest about what that discovery would mean. Confirming that life arose independently on 2 planets in the same solar system would be the most important scientific finding in human history. It would mean life isn't a freak accident. It's a tendency, a feature of the universe, not a bug. And it would mean the cosmos is probably full of it. But there's one more thing. The thing that keeps certain astrobiologists awake at night. Everything we've talked about assumes we're looking for ancient life. Fossils, chemical traces, molecular ghosts of organisms that died billions of years ago. But here's what the kaolinite, the subsurface water systems, and the hydrothermal evidence actually imply. Mars didn't just have habitable environments on the surface. It had them underground, shielded from radiation, fed by geothermal heat, protected. On Earth, we've found microbial life kilometers below the surface. In South Africa, scientists discovered bacteria living 2.8 kilometers underground, surviving on radiation energy from uranium in the surrounding rock. They'd been isolated for millions of years. No sunlight, no surface connection, no idea the sky existed, just rock, water, and chemistry, and they were alive. If Mars had the same conditions, and the evidence increasingly says it did, then the question isn't just whether life once started there. It's bigger than that. Could something still be down there? Right now, imagine digging a hole on Mars. The first few inches, everything's red, oxidized, blasted. Any organic molecule that was here has been shredded over billions of years. You keep going. A foot down, a foot and a half. The color shifts, the chemistry changes. And at 2 meters, the height of a doorframe, you cross the line. Below this, the radiation can't reach. Below this, the rock is a time capsule sealed since Mars was warm. If anything survived, if anything is still hanging on in some deep pocket of warmth and water and chemistry, this is where it would be. And this is exactly where Tianwen-3 is going to drill. That's what makes this moment extraordinary, and honestly, a little frustrating. We are closer than we have ever been to answering the question humans have asked since we first looked up at that red dot in the sky. The evidence is stacking up. The samples are collected. The technology exists. And yet the answer is sitting in a titanium tube on a dead riverbed, 225 million kilometers from the nearest laboratory, waiting for someone to come pick it up. In 2028, China will try. Something was found on Mars that wasn't supposed to be there. White rocks that whisper of warm rain on a planet that hasn't seen rain in 3 billion years. Leopard spots in ancient stone that mimic the fingerprints of living things. molecules too abundant for any non-biological explanation to fully account for. Sulfur sitting in the open like a buffet for organisms that don't need sun. And a sealed tube containing what might be the most important scientific sample ever collected on any world, by any civilization, in the history of this solar system. It's there, right now. The only question is who goes to get it, and what they find when they open it. I want to know what you think. If China brings back Mars samples and finds evidence of life, does it matter who makes the discovery? Or does it just matter that we finally know? Drop that in the comments. If this grabbed you, I've got another one on the discoveries reshaping what we know about the outer solar system. I'll link it here. And if you want to be the person who knows about this stuff before everyone else does, subscribe. I'll see you in the next one.